Guys, today I'm gonna talk about my ECTE 451 final thesis subjects. My topic is about facilitating distributed and renewable distribution in a restructured environment. First part is introduction. The NEM is working as an electricity wholesale market for supporting retailers and end users in most regions in Australia that constitute an interconnected network. In past, NEM has always operated on central dispatching and vertical integrating on power generation systems network. However, electricity power system consists of vast transmission line components that cost huge money on investment and upgrades. Due to the price of residential electricity has been increased, consumers start to change their mind over utilizing electricity habits. After that, electricity market demand starts to be stable. This leads to the new predictable investment cost on generation system to be 26 billion. Compared with the past, it's significantly reduced. The EMO operates Australian energy markets and also provides advice on power systems and contributes to development of reliability and safety in EM. Due to the results in this thesis, the participants have to agree a connection with each other. The connection means there are three different types of generation units, such as unscheduled unit, semi-scheduled unit, and full scheduled unit, based on the capacity and availability of participants' production. Next part is about literature reviews. In Australia, if a power generation is less than 30 megawatts, normally it can be considered as a DG. In general, DG can be renewable and non-renewable. In previous section, DG can be classified into two types like non-scheduled and non-market generation respectively by NER. However, it's hard to define DG in the NEM with the increment and of renewable generation. The main effects can be configured out as output of distributed power supply and infrastructure costs and connection cost. MadPower and Plexus are the software for solving DG placement problems, and they are quite different in using like OPF test systems, which it could not be found in Plexus but in MadPower. So it's hard to get OPF sub results in Plexus. Many generation data has to be modified in Plexus to achieve load cost price. But in MetaPower OPF, simulations can be built at different buses and loads and generations set values. For economic dispatch, Plexus can show while working on it. Through combining of using two software and offsetting their shortcomings, economic dispatch can be performed to study generation and load cost by Plexus. Plexus is being used in many countries to develop market and simulate their electricity market. It can have amount of changes that other software does not have, like EMO. It's continuously using Plexus in the future for market plans. About the problem development of this thesis, the expectation of this thesis is to reduce average and peak LMP on spot price by modeling and testing. In order to study the effects on placing DG and buses, IEEE 30 bus test system can be modeled, and then the sum LMP points of buses can be found reduced. It's done in MadPower cases, and a small 3-node triangle system will be presented to study the effects of DG placement with spot price. Results After 30 bus test system tested, it's much more economical to place DD on LMP high-value location buses and the other load bus like bus 8. In this system, luckily, most expensive LMP bus is the same with high-load bus, but in real electricity market, most expensive LMP bus might not be the same with most high-load bus. So further study has to be concerned about whether the effects of DG placement on load bus and LMP bus are the same. As a result, can be considered that most effective is DG should be placed on expensive LMP. After the test on a small model and Plexus, the spot price can be affected by load WM. Because Node 3 has a high load value, it increases the generation cost significantly. Even though the transmission line power flow does not affect the offer price on generation in this system, the transmission line power flow should be concerned to reduce in real life. It can reduce the cost of LMP on generation and save energy lost on transmission line. That is very economical to implement. However, in this system, the early period does not match spot price or interval because of the purpose of designing and interconnection capacity restrictions. The last part is conclusion. In summary, this thesis has briefly introduced the current electricity market, distributed and renewable generation. Distributed generation has significant effects on the electricity market with a robust electricity infrastructure. All people related with electricity market can get benefits. With the introduction of this thesis, many investors will start changing their eyes to invest in renewable resources. The beneficial point for the customer definitely is about the spot price. It's meaningful to spread out DG placement idea to reduce the cost on installation and security. This paper encourages using DG in spot price that is beneficial for company to invest in the future.